We're going to move on now and take a look at systems of inequalities. So the directions in your book say to graph the solution set. And then they say if there is no solution, you're going to indicate that by showing that the solution set is the empty set. So I just wanted to review, if that's the case, the empty set can be written using set braces with literally nothing inside, or you can put what looks like 0 with a slash through it. Okay. Just want to remind you not to mix these up. This is not the empty set. That is the set that contains one thing. The thing that it contains is the empty set. So it's one or the others of these if there is no solution. Okay. All right. Now I'm starting here with a linear system of inequalities. And I'm going to first of all just draw my working graph on which I'm going to graph the solutions to both of these inequalities. One thing that you may find new is I'm going to ask, in addition to this working graph, I'm going to ask for a final graph where you only show what the solution is. We'll talk about how that looks in a moment. Let's do our working graph first. Basically, I'm going to graph both of these inequalities on the same pair of axes. So if I look at this first one, my boundary line is y equals negative 3x plus 4. This is an inclusive inequality, so that would be a solid line. So we come up to a y-intercept here at 0, 4. Our slope is negative 3, so I'm going to count down 3 over 1, and I'll connect those dots with a solid line. Now I wanted y less than or equal to that. I know that y values are smaller lower down, so I'm going to shade below that line. And I'm just going to make it a little easier to see when we throw in our next inequality, I'm going to shade using these horizontal lines. Now, I'm going to graph the next one using red so that it's a little bit easier to read, because this starts to get busy when we have all of this information. So if I'm sketching y greater than x, my boundary is the line y equals x, but this time it's a strict inequality, so I'm going to graph that as a dotted line. Y equals x, the y-intercept is the origin here, but the slope is 1, so we'll come up 1 over 1, and I'll connect those dots with a dotted line. We wanted y to be greater than x, so I want to shade above this line, and I'm going to indicate that using a vertical shading here. Now, I do want to be careful. It's easy when I hit the axis to say, oh, I've hit a line, I need to stop. It can sometimes actually be helpful to take, I was looking for a straight edge, I found one, to take a straight edge and say, this is my boundary line. That's the only thing that makes me stop what I'm graphing, so that I don't use any other lines that happen to be on the page, like the x-axis, the y-axis, or the boundary line for the other inequality. I don't inadvertently use those to stop graphing. Now, of course, my solution is everything that's shaded twice. Okay. What's kind of nice is that's going to be what's checkmarked, because I used this combination of horizontal and vertical shading. Using different colored pens or pencils can also help to see that. You'll notice these lines intersect and they divide the plane up into 4 pieces. This part isn't shaded at all, so it doesn't satisfy either inequality. This part was shaded that first way, so it satisfies the first inequality but not the second. Where I've got the check marks, we satisfy both inequalities. And where I've got just the red shading, that satisfied the second inequality but not the first. Okay. Now, in some algebra classes, I would say as long as I can clearly see what's shaded twice, I would accept this as your graph. We're in pre-calculus now. The standards are a little bit higher. I want to actually just draw a working graph where I only show what satisfies both inequalities. So if I do that, now I might still want to draw in the boundary lines. Okay. I'm going to draw in this dotted one first because it was dotted. Okay. When I'm drawing in this line, which was solid, I'm going to put an open circle here, and it's not solid over here. Because the rule when you're graphing things is that solid lines, with the exception of the x and y axis, are considered part of the graph. This is not actually part of my solution because it wasn't shaded twice. This point right here, where the two lines meet, is only shaded once because it's on the black line that was included, but it's also on that red line that was not included. So that point is where points on this boundary line stop counting. And then what we shaded was this bit over here. So what our solution set is just this portion of the plane, not including that bottom line, not including that corner point, but including that top line as part of the boundary. Now, I'm okay if you find it helpful to draw in the entire boundary lines as long as they're dotted lines where they don't count. If you want to just draw the boundary of the shaded region, that's totally fine as well. Just make sure that it's clear that that corner point, which is where those boundary lines meet, is not included. That's something that generally, probably most of you, even if you've graphed these in algebra classes before, probably your textbook hasn't been super particular about that corner point. Our textbook makes the point that, hey, that's not included because it's not actually shaded twice. Okay. So that's your final graph. I'm okay if you find it easier to draw in the entire boundary line as long as the part that's not included is a dotted line so that I know that it's not included. But I will be looking for a final graph, not just your working graph. It's possible in some cases you might feel comfortable going right to the final graph and not supplementing with a working graph. That's okay, but I don't recommend it because you're more likely to make a careless mistake. So I'm going to recommend in all the examples that I do, I'm going to draw a working graph where I just graph both inequalities. It's two problems on the same pair of axes. And then I'll translate that to a final graph where I just show the region that I've shaded twice.